Now, another thing we're going to talk about is we're going to talk about solving a system of linear equations. So one thing to get out there on the table is when I say solve, what I really mean is find the point of intersection. That is the point that satisfies both lines. Spell that correctly. Find the point of intersection. So this would be, this would be where they intersect. And this is done in business a lot. So if you have, your cost versus your revenue, you want to find like your break-even point. Maybe there's something going on in the environment and you need to figure out, what is the benefit of using pesticides at that point in time. That would be something that you would possibly be able to model with this. So when we solve a system of equations, there's going to be two. It's going to be two here. At this, we will get eventually to three, but at this point, we're just going to be having two. So to find the solution algebraically, you just set the equations equal to each other. And you're going to solve for x and then plug x back into one of the equations to get y. So that would mean I were to give you 2x plus, so y equals 2x plus 3, and then y equals half x minus 1. Now, in order to solve these, so to find the point of intersection, I'll just set them equal to each other. And I solve for x. So that's going to be 2x plus 4 equals half x. And then that's going to be 4 equals half x minus 2x. So from here, I'll go up to here. It's going to give me 4 equals, and I need to turn 2 into a fraction with a denominator of 2. So that's going to be half x minus 4 over 2x. And that's going to give me 4 equals negative 3 over 2x. So then I would have x is equal to, and I would multiply by 2 to give me 8, and divide by negative 3 to give me negative 8 over 3. So now to find the point of intersection, we would substitute this back in, and I'm just choosing the top equation. You can choose the bottom one if you want. So that's going to give me, and that's going to give me, and then I'm going to turn 3 into a fraction with a denominator of 3. So I'm going to multiply top and bottom by 3, because 9 divided by 3 is 3. These guys are the same. And then that is going to give me negative 7 over 3, and that's my y. So negative 8 over 3, negative 7 over 3. Oh, come on. So another way to solve them let me change that. Another way to solve them is to look at a graph. And if you were to graph both of these, you would see that the point of intersection is -8/3, -7/3. So you can solve them algebraically or graphically. So that would be where the graphs intersect. So another thing that we can talk about is I want to talk about the break-even point. And that is where the cost of producing something is exactly equal to the revenue from selling it. So it's where you break even. Break even means where you have zero. So you've just managed to pay your bills, is what that is saying. So here I'm going to have a particular example. I believe this example is also in the book. So let's say a company sells light fixtures. So the company incurs a one-time cost of $250,000. Each light fixture costs $120 to make, and we can sell it for $140. That means that we only earn $40 from the sale of one lamp. That's what that means. So now what we're going to do is we are going to build a cost function, and that's C of X is usually how you will see this. So the way we're going to do that is the cost of making something. So when you talk about a one-time cost, that is immediately where you start out. And what that means is if I was going to graph how much money it costs to make these lampshades, in order to make these lampshades, I have to have a factory, hire people, but that will say that that's only a one-time cost, right? From the downtime from hiring people. So there's going to be a one-time cost of $250,000. So if we were looking at, X as the number of lampshades, as the number of lamps, and we were looking at the Y as the amount of money spent, before I even make any lamps, it's going to cost me $250,000. And that's what that means. So this $250,000 one-time cost is actually going to be that will be the y-intercept. So now what else they gave us? Well, we need a slope. Well, they gave us that each light fixture costs $120 to make. So that means per every one lamp I make here, it's going to cost me $120 there. So my rise over my run is m, my slope, which here is 120. Is our slope. So that is how much the cost increases by to make one more lamp. So our function is c of x equals mx plus b. Here our m is 120 and our b is the 250,000. So that's our cost function. So now it wants us to build a revenue function. And this one will be capital R of x. Now, your revenue is going to be how much. So revenue is how much you can get for selling one lamp, pretty much. Or you could say for selling X amount of lamps is another way of looking at it. So our revenue is not how much we make from selling that lamp. It's how much money they give us. It is not how much we make, but it's not how much we make. It is how much a customer gives us. So that includes the money we use to pay the bills and stuff. So it's just how much they're going to give us. So a mango cost $1, I give you $1. That's your revenue. Beyond that, I don't care how much it costs you to get a mango. I just care how much you sell it to me for. Which means that the revenue is just going to be a function, a linear function, that is x times the amount we sell a lamp for. And what that says is when we multiply the amount we sell a lamp for times the number of lamps we sold, that is how much money we have made. C, it wants us to find the break-even point. And how we're going to do that is we set the cost function and the revenue function equal to each other. That gives us our cost function is 120x plus 250,000, and we're going to set that equal to 140x. So, solving for x, we can see that we have 250,000. Let me do this in. So we have 250,000 equals 20x. Now, dividing everything by 20, we get x equals, we get rid of, let me see, if we were to divide these by 20, we get rid of one of those, and then we would divide this. We'd divide 25,000 by 2. So I can't do that one in my head. I'm sure it's something easy. 12,500. We get 12,500. Okay. Now, what does that mean? That means that we have to sell 12,500 lamps before we will break even. So better get to selling because that's a lot of lamps. And that concludes Chapter 2, Unit 2, Graphs of Linear Functions.